Hello and welcome to another tutorial. So this is the final part of the hybrid GOAP, the goal-oriented action planning series. Now in this video I'm going to be getting set up the support for being able to gather and store resources. I'm also going to be getting set up support for being able to, in our more sort of open world village setup, have the AI be able to return home. So that's going to be the focus. Now there is quite a lot of stuff we need to get set up for this, but that is going to be the main things we're focusing on. This isn't obviously going to be the end of the series overall. There is further updates and things like that I want to be doing to this. I have quite a lengthy list, but there will be a little bit of a break from the AI stuff after this comes out. So an important thing to mention is in the description, there are going to be 3 links in terms of with the code. So one is a link to the code as it currently is at the start of the tutorial. So that's ideal if you're wanting to follow along with this particular tutorial. The second link is the link to what the code it will be at the end of the tutorial. And the final link is a link to the completed package. So you've got all of those available. So let's dive on in because there's quite a bit of stuff we need to get set up. So one of the things, and this is actually one of the sort of first things we really need to get up and running, is we've got all of these resources and they do already have, information tagged on them in terms of what type of resource they are, things like that. But we need something that's going to be keeping track of all of that information. So what I'm going to set up, and this, again, similar to what we've done with other things, is going to sit in the sample stuff until this gets more abstracted into a generalized setup. So I need something, and this is going to be our simple resource wrangler. So the job of this is to be able to actually sort of just really keep track of all of the resources. So we're going to create an empty object here, simple resource wrangler, script on that, bring that up to the top here. So that is also going to get prefabbed, just because that's going to be a useful one to have, a prefab of that. So that's good. Now, in terms of what this does, is this is going to need to keep track of all of these resources, the storage containers that we have, and also have the ability to answer a bunch of sort of information. So there is already with this, one of the things I'm going to do is say that it's a singleton like that. Now I do already have a resource query interface, and that is going to give us the sort of core functions that we need to implement. So I've started pushing some of the things down into the core logic. And so there are these 3 essential functions that need to be answered for actually doing gathering of resources. Now there's a couple of bits of supporting information I'm going to need. So one of the things is going to be serialize field with a list of resource containers. So this is all containers. And then we'll also have a list here, and this is going to be our resource sources. That. So I just want to get those connected up in the scene, because that's something that's going to be pretty important for us to make sure we've got configured. So I'm just going to lock this, and containers is straightforward. We just bring in, I want to make sure we've got all 3 properly there. So that's good. Similar for the sources, we have our list of them here. Bring those in. So that's good. And then we can unlock that. So we've got a resource manager set up that's now able to be tracking that information. So, okay, we've got three sort of functions here that it needs to be able to address. So the first one is figuring out what resource an AI is trying to focus on. So there's a couple of steps to this. What I would do initially is, okay, well, let's store our resources and our type. So this is our focus type, and I'm going to default that to unknown. Then what I want to do is, with our resources, tally how many we actually have of each particular one. So what I'm going to do is for each, and we loop through our containers. And I want to track how much I've actually got stored. So I'm going to have a dictionary here that is going to be keyed off of Common Core, resources, type, and it's going to value-wise have a float. So this will be our resource tallies. So, okay, just in case, if a container is null, we'll skip it. So if container is null, continue. So tally how much we have stored. That's good. Now, obviously, depending upon the setup, you could have an interface that is not having to recalculate this all the time. For this, I wanted to keep it simple, but introduce that interface to make it so that there is a clear sort of approach of how stuff has to be implemented. So what I'm going to do is, okay, well, our list of ones here, I want to actually also keep track of a list. Again, Common Core resources, E-type. So I want to know what resources are actually available. So the first thing I would do after this is, well, okay, if available types, we'll check because the container has a resource type. So if it doesn't contain it, then I want to add it. The logic behind this is I want to be able to have a pre-built list that says, okay, here are all of the types of ones that are available. That's going to make life a lot easier. Then what I'll do is track the current amount. So the current amount is going to be 0. And then we want to attempt to get that. So resource tallies, we want to try and get the value like that. Now, what we then do is, okay, well, current amount plus equals container, and we should have our amount stored. And then all we do is write that back. I'll actually do that directly below it. So like that. So what we're doing is retrieving how much we've currently tallied for this container, if we've encountered it before. And then once we've done that, we go through and we figure out, okay, what is the total amount that we've got stored based upon this. So that looks good. What we could actually do is we could also do this in just one line. We could just say that. Might as well have less code if we can. So that looks good. So, okay, we now know exactly how much is stored for each available type. So then figure out the best resource to focus on. So I want to keep track of, okay, what is the lowest amount stored? I'll default that to our maximum float value. Then loop over this set of tallies that I've put together. So what I can then do is, okay, well, if KVP value is less than the lowest amount stored, then what I do is lowest amount stored is equal to that value, because we found something that's better, and I set the focus type to KVP key. So that means if we have any of the resources stored, then it's going to give us the information there, and it's only going to be based upon what containers exist. So because we've tallied this, we're picking the last one, makes it that we can very easily pick the appropriate resource, which is really handy. Okay, so we're now at a point where we know the lowest amount stored. Now, something that could actually happen here is that lowest amount stored could be 0, because it's quite possible at the beginning all of the containers are empty. So if lowest amount stored is equal to 0, then what I would do is I could actually say that the focus type is, and we'll pick a random one. So random range from 0 to available types dot count, like that. Now that's included system, so we want to get rid of that. That happened just as a result of it implementing this interface. So we do want to avoid that. Like, the reason for it is exactly the issue that it just started complaining about, because in the system namespace there is a random also defined there, and I want to make sure that we aren't accidentally using the wrong one. So there are ways around that, but I prefer, because of how infrequently I'm doing system dot, I just prefer to remove the using for it. So if the lowest amount stored is 0, then that means all of the containers are empty. So we just pick randomly, pick focus randomly. Now, conceivably, what could happen is we might get here and there are actually no available types. So if there were no available types, resource tallies would be empty. So it is a failure mode that could happen. So if available types dot count is 0, then I'm going to run the callback function, and I'm going to explicitly provide unknown and return no containers present, or no valid containers present. So that's good. All containers are empty, we pick randomly, otherwise we pick the one that is the lowest. So, okay, that's good. That lets us request a resource focus. What we then want to do is support being able to, for a particular focus, select an appropriate source. So that's pretty straightforward because we already know what our sources are. So what I would be doing for this is, we know that needs to invoke this callback with a game object. So, okay, we're going to have a game object, and this is going to be selected source, which will default that to null. Callback will get run at the end regardless. Then what I would do is build a list of candidate sources. So what I could do is have a list of game object, and this is going to be our candidate sources. That's new. So I loop through every source. We have resource sources, I believe. What did I call the variable? All sources. So we loop through all sources. Then, well, firstly, if that source is null, then it's no use to us. I also need to check, okay, well, that source, does it actually, support what I need? So that resource source, okay, well, if source dot resource type is not equal to our in type, or if the source cannot be harvested. So we would do a not, put parentheses around that. So that's good. At this point, we know that our source is able to be harvested and it is a matching type. So what I would do is candidate sources, add source, like that. And we would need to do source game object. So that's good. Then what I would do is, okay, well, if candidate sources count is greater than 0, then selected source is, and we just do a random range 0 to our candidate sources dot count. And that's it. So we pick a random source. So that's pretty straightforward for it. Now, unsurprisingly, our requesting a storage is actually going to be very similar to this. And this is one of those cases where, because this pattern I know is exactly what we're needing to do, I would just copy and paste it. Like, I could write it out again, and I could pretend that it's a case of, yeah, no, I never use copy and paste except for trivial stuff. I would always rewrite it out from scratch. It's not true, and I'm going to just be honest. But as you can see, I'm only pasting a screen's worth of code. So I don't go and paste very large chunks. I paste individual sort of sections. And then I do that so that it's easy for me to make sure that I'm properly updating things. This gets renamed to candidate storage. And this gets renamed to, I think this was all containers. Yeah. So this becomes can store. This gets renamed to container, like that. And that's actually all there is to it. So that's good. We've got all of the essential interface functions created there. Now, one of the key things that the goals are going to need to be doing, and we know that they're going to need to be doing, is figuring out how important is it to gather resources. Like, we can find out a focus, but we need to know, okay, how urgent is it for actually gathering a resource? So I want to set up a function for supporting that. So what I would do is we want to have a couple of sort of thresholds here. So I want a threshold that if the amount stored is below it, then gathering a resource is not a priority. If it's above it and up to a certain maximum, then that lets us know how where that desire should be. So okay, I'm going to have a desire to gather start amount, and we're going to say that, okay, the desire to gather should start if we fall below 100 being stored. And I'll say we also want to control where does that desire to gather peak. So where is it at its sort of a point where it becomes a critical emergency. So our desire to gather peaks amount, that is going to be 25. So that's going to be the point where the desire to gather will be at its highest. Then what I'll set up here is a public void get gather resource desire. We'll follow a similar pattern to what we've done with these other ones. We'll have a query, and that will have a system.action that gives back a float, and this will be our callback function. So, okay, in terms of with this, one of the things it is going to need to do is this same sort of tallying of what resources we've got available, but not exactly the same. So it's going to tally them, but I'm not doing any of this tracking of available types. I just want to know, okay, how much do I have stored of each resource? The searching for the one that is the lowest amount is also something that I want to actually do, because that's going to determine what is the most urgent resource to gather. So this is going to, now lowest amount stored is fine. So this is figuring out the resource that is most critically low. So what we're storing here is a common core resources e-type, and this is the priority resource or lowest resource type. So we'll default that to unknown, and we'll set that here. So with this, we now know what the lowest amount that we've got stored is, and we also know what the actual sort of amount is of that. So what I want to do is, okay, well, if the lowest resource type, if that is equal to unknown, then that means we don't have anything that we can really be doing, because that likely means there's no containers. So in that case, I would run the callback function with min value. So that's one scenario that could happen. The other scenario that could happen is the lowest resource amount stored could be greater than the resource, what did I end up calling this variable? Desire to gather. So it could be greater than that. If that's the case, then again, we don't actually want to, really gather resources. We could give it a very low priority. So we might return back, 0.01f. I could have that as a configurable thing. So gather desire when full. And I might make that really quite low. So I really don't want that to be a priority. The AIs should be looking at doing other things in that case. And that should be an F. So, okay, we've handled the case of we had no valid resource. We've handled the case of one where it's greater than that start amount. The other scenario we could have is the lowest amount stored could be less than that peaks amount, in which case we return with maximum priority. So I'd say actually that could be less than or equal to. So then the final scenario that we could have is what we know then at this point is we have a valid resource type. We know that the lowest amount stored is between that start and that peaks sort of side of things. So what I can do is I can work out our desire to gather as a mathf inverse loop. So we're using our desire to gather start amount, our desire to gather peaks amount, and the lowest amount stored. That's going to give us something that will start at 0 and will scale up. And what I can then do is invoke the callback function with that desire to gather. So that's good. That gives us all of the interfaces that we need to be able to figure out everything. So we can actually start setting up the particular behaviors that we need for this. So we've got a couple of sort of key essential ones that we need to put together. Now the goal action sort of set up for this, the resource gathering one is quite an involved one. There is a lot of components to it. And in particular, in terms of the state machine, this has the most complicated state machine of any of the behaviors. So we're going to have our GOAP goal, and this is going to be our gather resource, like that. So we're going to open that up. And we're going to have our action, which will get that created now too. So I'll have a GOAP action gather resource. That's good. We've got our goal, we've got our action, and we'll get those set up in a moment. The other thing we are going to need to populate is there is going to be a bunch of these sort of keys associated with this. So I'm going to create those now. So it won't be interaction. What this will be is our resource, and we'll have our focus type, or our focus, and that's going to be a new, and we don't need that. We can just go for the shorter syntax. So this would be self, we'll call this resources, and we'll say focus. So that's good. We also want to be keeping track of things like, okay, well, if there's a particular source we're heading to or a particular storage, so of source and storage. And I might actually put focus in all of these. The reason being that that's the focus type. This is the focus source, and this is the storage. So that's good. Those are some essential sort of keys that we're going to need in there. So the other thing then I want to do is I want to make sure these keys are being properly initialized. So I'm going to grab those keys, and I'm going to head to the base brain, because although a lot of this logic is living in the sample code, this is stuff that I do eventually want to be pushing into the base. So by having it there in the base from the beginning, it's there working as a reminder and to make it easier to make sure I remember to go and do that. So we'll have a current Blackboard. Now for the focus type, it's a set generic. So we'd have common core, names, and our resource the focus type, and we would set that to our resources type unknown. So that's good. Now the other ones are more straightforward. The other ones are just game object ones. So I'm just going to duplicate one of the existing ones to save time. So we've got our focus source and our storage. So that's good. Now the other thing is our AI is going to be able to hold resources. So we want to be storing that in the blackboard as well. So what I'm going to do is, in addition to those keys, I am going to grab a set of resource names from that enum. So we'll do system.enum get names, and we go for our common core resources e-type. So that's going to retrieve all of those. You have to put a type of. So what we're doing is populating the inventory. And I'm going to loop through all of those like this. And then, okay, well, the resource name, if it's unknown, I want to skip it. So if the resource name is this toString, we skip it because there's no point setting that up for things that like we don't need to keep track of, okay, what is our holding capacity for an unknown thing? And then what I want to do is we're going to have current blackboard. We'll do a set. We have a new fast name. And what this is going to be is, okay, well, we'll have self inventory. And I want to bring in resource name, and then we'll have held, so that'll be 0. And then I want to do a similar thing, but keeping track of our capacity. And I'll actually set this up as a separate variable. Make that an actual controllable thing here. So we'll have a serialized field. Oops. And that will be a float, and we'll make it 50. So that's good. It means our blackboard has everything it needs for being able to keep track of a particular resource, to keep track of sort of the storage there for that. So that's really handy. So, okay, what we can now do is start to actually get things like a goal and everything implemented. So the goal, relatively straightforward. Again, our good old GOAP goal base. Implement the required functions. So this is going to need a way to run that resource, gather resource function that we set up. So similar to what we've done other times, we'll have a serialized field, a unity event. Whoops, not that. So unity event, and this is going to take in a game object, and our usual pattern that we've done a lot by now of a system.action, and this is our get gather resource desire. So that's something that'll get linked up. So what I would do is, okay, desire to gather is we invoke that. So get the gather resource desire, invoke. we provide ourselves. Then we actually, so that we don't, we'll set that to float.min value. Always forget that the Unity events don't actually return. So then this is the desire. So we just populate our desire to gather value like that. So that's good. At this point, we know we have that information. So if the desire to gather is less than or equal to 0, well, our priority is going to be goal priority do not run, because there is nothing to do. Otherwise, the priority, again, very similar pattern we've used for these dynamic ones. We do a lerp. We lerp from medium priority to, and I would say, because resources are pretty important, I would actually say that that can go up to critical. Actually, no, probably high is enough. But we started at medium, so I think that's reasonable. We have our desire to gather, and then we just need to do our floor to half, to int, like that. That's good. That's all we need for the goal. So what I would do, I'm going to rename this to our RTS variant, like that. This gets our goal, so we'll attach that for now. And that was our gather resource goal. Let's add that there. Which that function-wise, we can link that up to our simple resource wrangler. And all we then do is get gather resource desire. So that's good. So now we can set up our action. So as I mentioned, this one is a little bit more involved. There's quite a bit we need to sort of set up in terms of the states for it. Now, it does have the ability to move. So that means we need our settings here for this. We don't need our start and update. We are also going to have things like, okay, well, our speed for gathering. So we're going to have a serialized field, a float gather speed, which I might say starts at 5. And a similar thing for our speed of storing the actual content. So our store speed, which I might say that's faster at 10. So, okay, good so far. Now this is going to be our GOAP action FSM. Implement stuff. Now in terms of supported goals, that's always the straightforward one. So supported goal types is our new system.type, and we provide type of GOAP goal gather resource. So that's all good. In terms of the resources that get actually used, that's going to be our usual set of legs and torso. And our cost, again, we're going to go for our sort of default fixed lowish cost. And that's pretty much all that needs. Now we get to the state machine. And this state machine has a lot of things that we need to do. So we need to select a resource to focus on. We need to find the navigable location to move to, then move to it, then gather it, then pick a container, find navigable location near it, move to it, and store it. So lots of fine-grained little sections that we need to do. In all, we actually have 8 separate states. So let's start to get these actually sort of set up. So I'm going to have state select resource. So that's going to do our usual logic, linked state machine, add state. Now this is a new state that we haven't actually had add support for yet. So we'll have state, and this will be select resource, like that. We'll have another one that once we've selected that, we need to get the resource location. So again, a linked state machine, add state. Now this one is a familiar one of calculating the move location. So we know with that one, we give it navigation. We know we give it our search range. And we know we're going to need a function that is to actually get the source location. That's going to be a local function. And that looks good. So that's the next one. Now I will, this function, not implement it yet, but I'll make sure it's got an interface for it down here. So vector3, like that. And it's got to follow the same pattern of all of our similar ones that we've done. Then we'll have another one that is move to resource. Again, this is our usual one that we've done of our move to. So we give it our navigation, we give it our stopping distance. Now it is not going to be in continuous mode. The repath threshold can be 0 because we're not doing any checks for that. But the whole reason for all this is so that I can actually override the name. So this, I'm going to put it as sm move to source. So, okay, we can select, we can move to it, then we'll have a state gather resource. That's going to do linked state machine, add state, a new sm state gather. And I want to give this our gather speed. That's why I set that up. So, okay, that's the first half of our states. Now I'm going to configure the transitions for those to begin with. So add a transition, and this is again going to be our fairly similar sort of setup that we've done of our state status finished. So having written all of this out now twice, this is stuff that I very much am going to do as a thing after this video. I'll do a later update that is a cleanup pass, because it is quite a lot that we are having to do here. And it's less than ideal of the repetition, and in general, I want to try and minimize any repetition that we've got in this, because that's really the point of this sort of structure, is keeping it clean and neat and avoiding that repetition. So, okay, so far so good. In terms of with this, I could go and set up the states for the actual storage side next. So we'll get to those being set up. Okay, so let's get the actual storage states set up. So they're going to follow a very similar process. So these actually can be kind of duplicated, because what we're doing is we'll be selecting a storage. That's going to then also be a different function or different class. Then we get our storage location. We move to the storage, and we store the resource. So that's going to be store, and that would be store speed. Similarly, this would be get storage location. And again, I will just get that function created down here, just so it is blocked out, like that. So that's good. Now we can link up the transitions for these. So it's going to mirror this sort of setup that we already had. So I can bring down another one here. So what we would have is gather is going to go to select storage. So we link those up. Get storage location is where we go to after select storage. Then we have move to storage, which we go to after getting the location. And then move to storage just goes and runs the store resource. So that's good, except I have done that all in calculate cost. So put that actually where it should go. So that's good. Now I need to do our usual, adding in the default transitions to finished and failed internal states. So that looks good. I can implement the logic here for our get source and get storage location. This is going to be very, very similar to a lot of stuff that we have done before, because these are going to be pulling from the blackboard. So we would have a vector3 source location is our common core constants and invalid vector3. We'll return that. So that's good. The storage one we'll come to in a moment, because what we would be doing is attempt to retrieve the source. So we would have a game object, source geo is null. We would do our linked blackboard, try and get common core names and our resource, and in this case our focus source. And again, like that. So if our source game object is not null, then what we would be able to say is that our source location is that transform position. So pretty straightforward what it needs to do for that. Our get storage location is going to be quite similar. So the main difference here is that we access storage. I'll rename these so it is consistent. Rename storage, and that gets renamed as well. So that's good. We've got those implemented. Now the main thing that we need to get sorted, so let's move to storage, is all of these new states that we have to set up. So we've got 4 new states that we need to go and create. So, okay, let's create our different ones here. So we'll have select resource. We will have gather. We will also have select storage. And finally, we'll have store. So a whole bunch of extra states for this. This is why this one is quite a lengthy one to get set up. So let's begin with our selecting of the resource. So this is sort of the first big initial thing that needs to happen. So we'll have our state base like that. Implement our functions as usual. So fairly similar pattern that we'll have with this. On exit, nothing we need to do. And our tick internal will return the current status. So everything happens in this on enter internal. So this needs to be able to link over to our resource wrangler. So it needs to be able to call the appropriate interfaces here. So what I'm going to do for this is there's a couple of ways I could go about it. So one option is providing that interface. So we know that we have the resource query interface like this. So resource interface. And then in our onEnter internal, well, if we don't have that interface, then it's pretty straightforward. We have to fail. Otherwise, we'll assume that we have finished and been successful. What this also means is that with that interface, we have our state select resource. So we would need to have that resource interface provided to it. So the resource interface is going to need to be passed in like that. We'd have in resource interface. We will take in our custom name just to make sure we're always supporting that. So that's good. Then what we would be doing down here is, okay, first thing we want to do is try and pick a resource. So I'm going to get the owner of the blackboard. And then, okay, well, our resource focus is we take our resource interface and request a resource focus. We provide ourself. Now this needs to link to a system.action. So what I would be doing, so this is a bit more of a generic sort of setup for it. So that would link to Common Core resources E-type unknown. So I would request the resource focus, and we would have a Common Core resources E-type. That. So that's good. Now that could have failed to select an appropriate focus. So if the resource focus is unknown, then we fail out because we haven't successfully managed to select one. Then what we want to do is we want to actually see if we can get an appropriate source. So our resource source is a game object. Null, and that looks good. Now that actually is a particular type that we're using. So what I will actually change is I'll rename this to focus type and focus source. So similar logic, resource interface, we request a particular source, we'll give it ourselves, we give it the type, and what we will get back is a callback here. So that's good. So this could fail to find a source. So again, if it failed to find a source, then we return failed. So that's good. Now at this point, we have a source and we have a focus. So we can actually set those. So we could do Blackboard, and we could do a set generic for our Common Core, our names, and our resource type. So that looks good. We would also then be able to do a set for the actual source. So we'd have our, not focus type, but our focus source. And that would be our focus source like that. So that's good. What I would also do is do a up here just to ensure that these are properly wiped out. I would do a game object null, and I would set this to unknown, just so we're properly clearing things out. So we're attempting to pick a focus, and here we're attempting to pick a source. So that's good. That will actually, do everything we need in terms of being able to get that information. So that's great. So, okay, that's all we need for that state. Then the next one that it runs is our gather one. So we're going to get it implemented. So with our gather one, that again, our state base, that. Now we already know that this was going to be taking in gather speed. So that's a thing we already know that we need to be doing. Good. So I'm going to store that. That's great. So far so good. Now I'm going to tell it to implement the individual ones. So, okay. Now with this, on exit internal, doesn't have anything it needs to do. The tick is going to have logic that it needs to do, and so will the enter. So there is a bunch of stuff we need to attempt to actually do. So first thing I'm going to do is in the on enter, I need to try and actually check, do we have our source game object? So our source game object is going to be default that to null. We will try and get our common core names and our resource source. So quite possibly this could be invalid. So if the source game object is null, then what I would do is we just immediately fail out like that. That's good. So for whatever reason, the source is no longer valid. We can't actually do anything with it. With that, then there is actually the logic script for the particular source. So that is actually something I want to keep a cache of here as well. So what I would have is common core resource source, and I want to try and retrieve that. So I'm going to say if we source game object try get component of our common core resource source, and outputting that to our source. So if that fails, then we fail out the entire process. That's good. Now, the other stuff that we want to check here is, well, do we actually have a focus? And is that focus valid? So I will actually check that first. So I'm going to have focus type, and that is going to be common core, resources, e-type, and unknown. Then we'll try and retrieve that source. Try and get. So that needs to be a try get generic with this particular type provided. And it's going to be a try get generic of common core names and our focus type. We output that to focus type, and the default is unknown. So good so far. What I would then do is, okay, well, if focus type is unknown, then we failed. So no point doing these further checks or slower stuff if we didn't manage to get the correct type. Now, although it shouldn't be necessary, I'm going to make sure at this point that source and the type is equal to focus type. And we'll actually check if it's not. And if it's not, then we'll fail. So I want to be really extra cautious with this. So if the focus type doesn't match, then we fail out. Or if the source by this point is not able to be harvested. So if it cannot be harvested, then we're done. So that actually, there's a lot of checks that we need to do for this. A lot of checks that we need to do. Now, I want to keep track of the amount that we're holding and things like that. And I want to be relying on that from the Blackboard. Now, this is something where we were constructing the names here. So we had this logic here. Now, this is something where it's a little bit less than ideal if we're kind of creating and working with these in multiple places. We can get away with it, but it is less than ideal. What I will do, though, is I will set up here a common core fast name amount held key and a common core fast name capacity key. So these are essential ones that we want to actually have. So our amount held key is that, and our capacity key is that. Now we just need to get the resource name, which the resource name is our focus type toString. So it's a little bit involved. I don't love the sort of creation of the keys like this. Like, it is something that the fast name support. It will uniquely map, so it is viable, but yeah, a little bit less than ideal. So then what I would do here is return. Well, if we already know that the source can actually be harvested from, so we actually can just return running. So that's good. We have it being able to do all of that logic for checking. Now for the tick internal, that's a little bit not too horrendously involved. So we would say, okay, well, our amount held is our blackboard, get float, and we have our amount held key. We have our capacity is our blackboard, get float, and our capacity key. So we can figure out the amount that we want to try and retrieve. So the amount to retrieve is a mathf minimum of delta time, which gets passed in. So that by our speed, and the capacity here minus the amount held. So that's actually our spare capacity. So that determines how much we actually try and collect. So then what I would do is I would say, well, amount held plus equals our source consume and our amount to retrieve. So that's good. Then I would set in the blackboard, we can set our amount held key to amount held. So we have consumed stuff, we have updated the blackboard. Now, in terms of whether we are actually still running or not, so, okay, well, if the source and we cannot harvest anymore, then I'm going to say that we are finished. So not failed, because we haven't failed at this point. We've just actually finished doing this step, and we can store what we've already got. I could do an additional check here of if the source, we can't harvest it. I could check, okay, is the amount that we've held nothing? But this should be completely fine. So we can't harvest anymore from this source. We could also check or mathf approximately. So if our amount held is approximately the capacity, then we're also done. Otherwise, we return that we're running. So there's a lot that we had to set up for this. It's a huge amount to actually get this up and running. The good news is the logic for this is a lot simpler for doing the storage side of things, and it's very similar in terms of what the behaviors are. We do want to go back to Unity, see what areas it's grumpy at, because it will be grumpy with some areas. So this is going to need our actual sort of interface. So this is where what I could do is we have a simple resource Wrangler instance is what we can pass in. So that's good. We've made everything happy other than our select storage and our store ones. So it's getting progressively less grumpy at us, which is progress. So that's our select and our gather done. Now, in terms of the logic we need to have for actually doing the selecting of the storage, again, this is going to be off of our state base. Get rid of all of this. So this is going to follow an almost identical pattern to the selecting of the resources. So it's going to have that resource interface as well, because that's how we discover the things that are out there. So we implement everything for that. So as with the selecting of a source, our exit does nothing. Our tick just returns the current status. And we have a constructor. Oops. Select storage. that. And as always, support for having a custom name. So that's good. And that just gets linked over. So now we can set up the handling for when we enter this. So reasonably similar to what we were doing for selecting a resource. The actual logic here is very, very similar, but it also bears some similarity to the actual gather one as well. So the first thing we want to do is, if we don't have a valid resource interface, then we're going to fail out. We'll default to saying that we finished. So, okay, couple of things I want to retrieve. I want to firstly do our usual one for getting our self. So that's good. Now what I want to do is I want to attempt to retrieve the resource focus, and from that then I'll pick a storage. So I'm actually going to grab what we were doing here for getting the focus, because that applies directly for this. So we get the focus, make sure that's correct. So get the focus type, and I will comment these as well. So getting the focus type, this one is get the source game object, and this check that the source is valid, because it easily could not be. So okay, we've gotten the focus type. Now what we want to do is we want to attempt to actually select a focus, select a storage location. So we can request a storage. We provide ourself. We provide a focus type. And much like we've seen, so this is in storage. And what we would have is, so we're selecting a storage container. So we'd have game object, storage game object is null, and we'd set this like that. So again, if that storage game object is null, we fail out because nothing to do. If it was successful, then we set that as our actual storage focus. So we've got our focus storage, gets set like of that. That also means we want to, again, for our safety, up here, always default that to null. So a game object, null, like that. So that's good. That's all that select storage needs to do. And if we go back to our action, then that gets our simple resource Wrangler and the instance. So now it's just our store function to set up. So, okay, it's going to be, not surprisingly, very, very, very similar to our actual gather one. So again, SM state base. We are going to pretty much have this similar set of things that we need to be storing here. So I'm going to bring these over just because it is common stuff that we need to have. Now this is not going to be a resource source. This is going to be a resource container. That's good. So we'd have our state store, and that's going to have not that. That'll have our in and our speed and our usual in custom name, which defaults to null. Do all of the usual logic and store the speed like that. So far so good. Then we'll do our default implementations of these. So exit, nothing we're needing to add in there at this point. Tick and enter are obviously going to have a bunch of logic. Now the enter logic here is going to be very similar to what we were doing in gather. So we want to make sure we do fairly similar safety checks and fairly similar sort of population of things. And again, like I did before, this is actually one where I would duplicate this because it's already doing a lot of the logic and it gives us a safer way of setting this up. Because a lot of this is exactly the same. We still want to get the focus. Now we want to get, in this case, the container game object. So I would rename that to container game object. The key we're retrieving changes. And actually I might rename that to storage game object. So what we're retrieving here is the container. So that's good. I could also just call this storage, just to sort of match. So, okay, well, the storage, I want to make sure, and we need to, that's correct there. This here changes to resource container, obviously. So our container, or our storage, will actually have a can store function on it. So we're checking that the container is valid. So the logic is largely the same. That's why I kept it and duplicated it like this, because it is doing pretty much identical behaviors. So it means that it's a little bit more reliable for making sure things are working. And the same is actually true for the tick logic. The tick is very, very similar. The difference is that it's counting down rather than up, is really the big difference. Okay, so let's update this. So for one thing, we don't have capacity. The amount that we retrieve, rather than being a min, it's going to be a max with a maximum of either the, this gather amount or the store amount or 0. Because we might be at a point where there is nothing left to actually sort of store. So we would do storage, store, amount. Now we want to change the name of that to, that should be amount to store. So that line goes. What we end up doing instead is amount held minus equals amount to store, like that. So that's good, and we update the key. Now, what we would be doing is, if our storage can't actually hold anymore, so if our storage can store, that's no longer true, or if the amount held is less than or equal to 0, then we are done. So that looks pretty good. That should give us sort of pretty much all the key bits that we need there for that. So then with that, our action is done. So if we go back to the game here, now we haven't connected up our action for this. So we're going to link up our gather resource action. So that's good. Now this is one that I will make a new variant and do the renaming. So that's good. Now let's just test out how this works, because we could run into issues. There's a lot of stuff we set up for this, but let's run this. And okay, so we can see it's gathering resources. That's a high priority. You can see it's storing wood. So that's getting loaded up into the inventory. It'll load up to 50 of that. Now it is going and heading to actually store the resource. And we can see the capacity is going down and much faster as it stores it. And now the focus is on food. So it's going and grabbing that. So that's really handy. It's working, it's doing the bits of logic that we need to. If we added in additional ones, they'd likely end up gathering different resources. So if I duplicate this and we have A and B, and what I'll do is I will just move these so that they are in different locations. And let's run this. So A is gathering, or B is gathering water, and A is also gathering water. Now they'll likely be heading to, and we can see they are actually heading to different sources of that. Now in this case, they randomly picked both the same sort of resource to gather, but because they'll bring back such a large chunk of that resource, there'll actually be a lot less that they need to go and gather after this. So, because we don't actually consume any of the resources. So again, that's actually decreasing. So B is now heading off to go and grab water, go and grab wood. A is trying to also do the same thing. So they do their obstacle avoidance, because this is using very basic setup, so they don't actually have good obstacle avoidance. So sometimes they do get a little bit stuck on each other. That's something where this is using just very, very basic pathing. But that's working nicely for gathering and storing the resources. Now, the one thing we do notice there is it isn't clearing the sort of storage ones once it's done, or the source once it's actually finished. So what I'm going to do is in our setup here, when we have selected a resource, that's fine for it to keep that there. But when we go to actually gather something, once we've finished that gather state, I want to actually clear out that focus source. I want to do a similar thing with the storage side of things after it exits that store state, so that it's not keeping everything around. And I would also say we should clear out the focus once it's completed the storage as well. That'll just mean it's not keeping a whole bunch of references in the blackboard that it doesn't need to. So we'll see now with this, it's going and heading to the food. Once it's finished gathering that, and we can see one's focusing on food, one's focusing on water. So they will be able to gather different things. And then that nulls out the source as it's now heading and doing the other particular bit of logic. One thing that would be handy with this is the state machine's not highlighting what the current state is. So I'm going to close all of those, and I'm going to go to our state machine. So this is our SM, I believe it was instance. So I want to look at how it handles the debug display. So it is indicating if something is selected and it is the current state. So then if we take a look at our state base, so when this is doing the debug display here, so there's nothing specific that it's doing for if it is selected. So what I'm going to do is actually modify this, and if it is selected, we'll do something a little bit different just to make it clear what sort of state it's in. So what I would do is we might just put an asterisk there. So now we should see with this, it's a little bit clearer. So we can see it's in move to source, and then we should see it changes to gather. So that just makes it a little bit clearer about what's actually happening there, which is good. So with that working, we now want to get the sort of final section working for the village. Now the village is where it's going to get a little bit interesting. So I'm going to bring in the GOAP AI. This is going to be our village variant. Now this is going to goal-wise. It is going to need the gather resource as well. And it's going to need our actions for gathering the resource. Now, this is something where we did stuff slightly differently between the goal and the action in terms of being able to retrieve this sort of desire. So one of the challenges with this is the village one needs to be able to dynamically instantiate these, which means anything that's a reference to a thing in the scene is not going to work. So what I'm going to do is I'm actually going to modify this similar to what I did with the action here. So the action was referring to the simple Wrangler instance for being able to pass in an interface. I'm going to need to do something similar there for this so that it can actually be properly linked up. Again, this is having a bit more of a dependency than I would ideally like, but it is something where at a later stage I do have plans for being able to disconnect these things. It was just too much and too large of a system to try and add at this particular point. So for now, this is going to use system Wrangler, sorry, our simple resource Wrangler, and we already have our get gather resource desire function. So we're going to just use it for now. Really just look like that. That allows us to get rid of this. So it means that we don't have any references that need to be set in the inspector, which is going to make it easier for being able to have this just be dynamic. So the final goal that we want to get set up, and it's a pretty straightforward one, it's going to be a GOAP goal return home. This one doesn't actually need any new states. So what this is going to need to do is it needs to work out, okay, how important is it for it to return home? So it's going to have some priorities there that are dynamic. So what I need to be able to do is a couple of tuning options. I want a distance at which it will start missing home. So missing home start distance. That'll kick in at 50. I want to, and actually there's no reason that can't be a float. We'll have a missing home peaks distance. So the distance at which it is at its maximum value. So 100. And then I want an option for being able to say, okay, once it gets within a certain range, do we reset it? So, okay, our missing home reset distance, say it has to get within 10 to be able to actually reset it. So we can prepare for our planning. Well, I want to be able to get the home location. That's going to be a pretty important thing. So I'm going to have a vector3 get home location, which I want to set up another key because we have our current location, things like that. Going to create one that what it will be is our home position, like that. And we'll make sure that that gets properly set in our base brain, and that should be being set here. So wherever we spawn, we'll treat as our home location. So that's good. So what we would do here then is a vector3 home location is our usual, not combined instance, common core constants invalid vector3 position. And we'll do our usual sort of setup where we'll try and retrieve a actual sort of home position. So we'll say our linked blackboard try to retrieve, and we want to retrieve our common core names and our home location, and we're going to output that to home location and our good old defaults of the invalid vector3 position. So that's good. So what I could do then is just return that because there's nothing fancy we need to do with it. So, okay, vector3 home location is get home location. Now the reason I set it up as a function here is if we're wanting to do anything fancier later, it makes it easier for ourselves. So if, for whatever reason, that is our invalid vector3 position, then our priority is just do not run. So like that. So that's good. Otherwise, we actually can start to do some calculations with the priority. So there's a few sort of things that we need to be doing. So firstly, I want to get the distance to home squared. So that's something where firstly I would get our home location, sorry, our current location. So that's going to be our linked blackboard, get vector3. And this is one that I could also, again, set this up as a something that there's a little helper function for, like we did with things like the self. But the distance to home squared is going to be home location minus current location. And we'll just get our square magnitude. Because there's a bunch of tests we can already do with this. So, okay, well, if our distance to home squared is less than our missing home start distance times by the missing home start distance, then in that case, we shouldn't run. So our priority is to not run. Otherwise, Well, the other scenario we could have is that it could be greater than the distance that it peaks at. So it could be greater than or equal to peaks, like that, in which case the priority is going to be our high priority. Because they're really missing home, so they want to very much be returning back. Now, we want to not reset the priority. Like once we've decided it's urgent to head back, we actually want to prevent the priority decreasing because we want it to still stay important. Because once it hits a threshold of I'm really missing home, if it takes, 5 steps towards home, that shouldn't lower the priority. It's still missing at the same amount. So I'm actually going to set up here new priority is equal to whatever the current priority is. And these ones are going to update that. And then this one here, we need to do an interpolation. So our interpolation factor is going to be our inverse lerp. Genuinely one of my favorite functions. So missing home, start distance, our missing home peaks distance, and we would need to do a square root of our distance to home squared, like that. So doing the square root is unavoidable in some cases, but we delayed it until the last possible scenario where there's no other option. And then what we would say is the new priority, we would do a mathf floor to int and a mathf lerp from our low priority up to our high priority with that interpolation factor. So that's good. What we can then do is, okay, we need to check, is that distance beyond the reset distance still? So if the distance to home squared is greater than or equal to our missing home reset, like that, then our priority is the higher of priority and new priority, just so that we don't lower it until we're back at that reset point. Otherwise, we just do our normal logic. So it's a little bit more complicated, but the reason for this is, like I was saying, once they've started missing home, that is something that we want to have persist. So having this sort of reset distance works well for enforcing that reset behavior. Then we can head over to, we'll attach that return home goal like that. And then we can set up our return home action, which is going to be pretty straightforward. So I'll have GOAP action, return home, and we'll get this set up. And this is going to be very familiar. A GOAP action, FSM, eliminate all of those. Now this is doing movement, so unsurprisingly, with it doing movement, we need to have our search ranges and stopping distances. We need to let it implement everything. Supported goal types is our new system type and type of, and just our GOAP goal return home. That. Our required resources are our usual set of ones of the legs and the torso. 90% of the actions tend to be like that. That's sort of very intentional. And this is going to have our standard fairly low cost. Now our actual state machine for it, we don't need to create any new states, and it's a really simple state machine. We would have state get home location. It's going to be our linked state machine. We add a state. This is our new, and we're doing our calculate move location, which means we give it our navigation interface, we give it our navigation search range, and we're going to need a function to get that home location, which conveniently we already have a reference for what that should look like, because we have that already here. So I can use that exact same function. There's no differences in what it does. Then the only other state that it needs is our move to location, which we've already got everything we need for this. It's our move to state. So we again provide navigation and our stopping distance like that. We can set our simple transition that we need to. It's a very simple transition, and it is the typical one we have done a whole bunch of times. Now we could use finished move, or we could just use our F status one. Either is going to work here. But if it's finished, then it goes to the move state, and we just go, and then here are adding of the default transitions, finished and failed. And that's it for the state machine. Doesn't need anything extra or fancy. We're going to add that return home action to it. And I'm going to create this as its own variant. Name that. So that we can remove it, and in the village we link up so that it knows that's the prefab to actually spawn. So that'll mean it ends up with a lot of different ones that can actually spawn. So we just want to check that also that we've got things like we haven't got our resource manager in here yet, so we'll bring in our resource wrangler. With that, we want to link up our containers. So food, water, and wood are all linked up. And we will lock that and link up our resources. Sources are in there, so everything it should need is connected up. So let's test this out, see how it goes. So we need to move way over to actually see what's happening, but they are doing their thing. I said the obstacle avoidance on them is not amazing. It's an area I haven't really done a lot with yet, so they don't do a great job of that. That is something we could also handle as a goal, but we can see they're wandering around. There wasn't really much of a need for it to do other stuff. Gather resource and return home. The priorities of those are currently to not run. We can check and see what other things are doing. So everything is pretty much not gathering any resources. So that's something where we might want to check and see, okay, why is nothing trying to gather a resource? So because we did go and make some modifications here. So we could check in our prepare for planning Okay, it's going and running this logic. It's checking that desire for gathering resources. And so it goes through the tallies. It does find ones there, so that's good. So it's not failing to actually select one. So far that looks all correct. Now the key we noticed there, however, was unknown. So if we take a look at what it's got in terms of our containers, the resource type is not correct on them. So that's why the resource gathering is failing. So if we take a look at food and water, so that can happen with transferring stuff between scenes. It can get those incorrect. Now I do want to then also, given it was wrong on the storage ones, and we can see it's actually wrong on the resources as well. So we should fix these, and these have got it correct on the prefab. So it's like the prefab has lost some bits of data there. So we could revert that on those. Same for on the water ones, and same for on wood. So that should work a little better. It should be able to, in theory, gather resources then. So we can see now gather resources is actually able to run. We can see them fanning out. This one's heading to gather wood, another for water, another for food. So a couple of ones heading and grabbing different things. And that looks like that's working. The one thing we did notice with sort of testing this in particular with something like the village scene that's running a lot of ones is that the debugger can easily run out of space. So what I'm going to do is I'm actually going to make a few changes to the UI here. So I'm going to create a scroll view, debug text, scroll view. And what we will do is bring the debug text into that content. Now the scroll view, I'm going to make that so that that fits inside the entire area. We'll turn off that background image. Now I want to get rid of the horizontal scroll bar because we don't really need that, which means I can actually delete that. The vertical one, I want to keep that, but we make sure it takes up the full space. Then what I would do for the debug text is we give it a content size fitter, and we change that to be preferred size. On the content container, we do the exact same thing, preferred size, but we also add a vertical layout group that has full control over the width and height of the chart. So that looks good. So if I go back, then that will have updated that prefab. So if we test that, now we actually get a scroll bar, so we can easily scroll and keep track of things, which is good. So that scene is working. We can test and make sure all of our other scenes are working. So our village one, that worked. So our SimStar one is working as well. Our RTS one, that's working, and it has the advantage of having that scroll view now. And then finally our first person one, where we can see that the AI is wandering around, and once it sees us, wherever we end up actually being, don't even remember where I put the AI. It's currently wandering around waiting somewhere, but it will be able to find us. There we go. So now it is actively chasing us. So that's good. We have all of our different scenes up and running. We have our framework there for this. So all of the different key pieces are up and running. Now, there are going to be further updates that I will be making to this in future, because there's a lot of areas where I want to improve the interfaces to make it a bit easier to work with. And this is going to be sort of my primary test bed for developing and extending AI things for quite a while to come. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck on a like and subscribe. It really helps out. It's really appreciated. As I mentioned, in terms of with the code, there are 3 links in the description. You have the code as it was at the start of this project, or the start of this video, the code as it was at the end of the video, and a link to the actual package that you can directly install. So all of that is available. If you have questions, chuck those in a comment below. And if you are looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description also. But until next time,